Okay, here's we'll call this set 4. So we've had a set, well, basically 1, 3, and 4, and I gave you that other problem earlier today, so this is our next 3 we're going to do. And we're going to use the double angle formulas to find the exact value. So we can't find the cosine of 105 degrees and squared. We don't know that, but we know that this looks like cosine, cosine, sine, sine. So this looks like the cosine for the double angle formula. All right, we derived that, so you just have to kind of remember this, but anyway, it's real easy to derive because we can think of cosine of x plus x, and that's cosine, cosine, sine, sine, cosine x minus sine x sine x. So just by applying this sum formula that you really need to know, you get cosine squared x minus sine squared x. So if you forget that, you're going to derive that, and that's what this looks like. So this looks like basically, and that's the cosine of 2x. So to simplify this, this is going to be the same thing as the cosine of 2 times 105 degrees. It's our 2-angle formula. That's the same thing as the cosine of 210. So what's that going to be? Well, that looks like that's actually going to be the same thing as pi over, or sorry, I guess that would be pi over 6. And then that gets us over like this. If we look at our reference angle, this is my 210, so that's 180 plus another 30 makes 210. So it looks like it's going to be 7 pi over 6. So it's the same thing as the cosine of 7 pi over 6. So it's down over here, that's our reference angle. This is 180 plus 30 is 210. So that's our 210 degrees. And look what quadrant we're in. We're in the 3rd quadrant. So the cosine is going to be negative. And what's the cosine of pi over 6? Square root of 3 over 2. So that's your exact value. Okay. Let's take a look at this now. This looks like this is our 2-angle formula for the sine. And remember, you can derive that by using the sine of x plus x. And then remember, that's the same thing as sine cosine plus cosine sine. And then this is the same thing as this if we use the commutative property. So I've got one of these plus one of these is 2 of these, so that equals 2 sine of x cosine of x. So that's how you derive it. It's not hard. And that's the sine of 2x. So it's easy to derive. It doesn't take long if you forget it. So that's what this is. So this is going to be the sine of 2 times 15. And that's just the sine of what? 30. And the sine of 30 equals 1/2. So that's nice and easy. We don't have to mess around with other quadrants on that one. In the same respect, this is the same thing as the 2-angle formula for tangents. So let me move it up a little bit so you can see it. Sorry about that. And again, you could derive that same thing, the tangent of x plus x. Okay, that just equals the tangent of x plus the tangent of x all over 1 minus the tangent of x times the tangent of x. And that looks like 2 tangents of x all over 1 minus the tangent squared of x, and that's going to be the tangent of 2x. And that looks like what we have here. This follows this form. So this looks like this is going to be the tangent of 2 times pi over 12, which is the same thing as the tangent of pi over 6, and the tangent of pi over 6 good old unit circle, it's going to be 1 over the square root of 3. So that's how you handle those. Make sure you can derive these. They're real easy to derive. The main formulas to remember are the sum and difference formulas for sine, cosine, and tangent, and then from those you can get the two-angle formulas. Those are very, very valuable, especially in calculus.